Okay, so the next thing that we're going to be covering is lighting and rendering. So I started to go over this a little bit on the first day of class, but we didn't make it through all of the slides, so I thought I would do a quick, hopefully, recap now that just kind of covers what lighting and rendering are. So we'll start with lighting. So in Maya, we have lots of different types of lights that we can add to our scene. And you can set the parameters of the lights like we've been doing, setting parameters of our objects and our polygonal shapes. Those are going to be set in the same place in the attribute editor. So you can see in this slide a bunch of like color and intensity. A bunch of other options are going to be available to us in our attribute editor. We also are going to use Skydome. Like I said, I like to use the fastest, cheap and dirty ways to get really great effects in this class. So one of the best ways to get realistic dynamic lighting is to use something called a Skydome. And that is basically like using an HDRI image that you see on the right. So that's a 360-degree photograph. So it wraps around a sphere to create a seamless photograph. And then that photograph is actually placed in the Maya environment. In this example, you can see it produces both a reflection off of reflective objects, but it's also casting a shadow. So you can see in the photograph here, the sun is bright white. So Maya and Arnold are using that photograph and the color data from that photograph to recreate lighting. So anything that's bright white will Maya and Arnold will interpret as a light. So this sun is kind of coming over from the top, raking down the side of this object and casting shadows. You'll also see it's kind of a small image. So you'll see that there's like a complex light bounces. So some of the light on this little guy is quite warm, and that's coming from the ground, this like brown ground. And then some of it's really cool, like these blue highlights in this little dimple over here. That's the color from the sky that's getting calculated in there. So you're getting really complex light bounces and really complex color bounces with the Skydome. So we'll be using that. There's also things like atmosphere. So here you can see these rays coming in through the windows. So you can also create parameters for those effects. It's called volumetric scattering. We might not get into that today, but if you ever did want to kind of play around with that, it's in our render settings and using an environment map and using a volume scattering. We'll talk about that later. So good lighting is a combination of lots of light sources and lots of types of lights. So shading, we'll get into in a little bit. We're going to be using our default materials, the materials that just come for free when we add a new polygonal object. But just keep in mind that lighting is one component, but lighting interacts differently with different objects. So it either kind of bounces directly off of an object, and that creates a shine, or it kind of it scatters evenly or along like a matte object that is called diffuse material. And then, but usually it's a combination of a few different types of materials. So those material properties, shiny or matte or diffuse, combine with color image data, and that is our texture, our image texture on the surface of an object. So here we have a color image texture of kind of oxidized copper, and here we have a color texture that is kind of a bright shiny copper, and then here we have a image texture that's concrete or asphalt. And it's combining with a suite of material properties like shininess, or does the light kind of penetrate and scatter around inside of an object, and that gives it kind of translucence, things like marble or skin. That's called subsurface scattering. So shading is a combination of all of these material properties. And shaders are these kind of shaders from a library that you see here, are a bundle of those assets bundled together that you can kind of apply onto your material pre-made. And so we're going to be using a lot of those pre-made materials in Arnold. So here we go. That's you can also use node-based editing if you get really into shaders. This is kind of part of my favorite part of Maya. So we might not get into that in this class. One, it's kind of buggy and it starts crashing systems, and then two, we just might not need to. But the other thing that works in concert with the image texture and the material properties are whether or not we have bump maps applied. And usually almost all objects that you'll see in games or in cinematics rendering have this application of what's called a bump map. And this is a way that you can fake geometry to get what looks like a texture on top of a surface, but you're actually not adding any faces. So it's really computationally efficient. So that's just using a map that sometimes looks like this beautiful purple image, but you can also use black and white images. So we're going to be using a renderer called Arnold that for a long time was separate from Maya, and then I think around 2017, maybe 2016, it started becoming bundled in the Maya download. So hopefully all of you downloaded Arnold with your download. It was one of the little check boxes there on the front option. If not, I'll show you how to import it. So the render engine is going to take into account all of the material properties and the light properties and the geometry, and then calculate how a light would bounce around in your scene, given all of those properties. So right here you can see it starts out really grainy, but by the time it finishes rendering, it's this beautiful kind of like raster image. And we all know the difference. So until what you've been screenshotting are like a render preview, right? Once you render, it's a static image. It no longer has any of the geometry details. It no longer has property, like the material properties in there. It is just like a JPEG image, a rastered image. There's lots of different like rendering engines that you can use, but each one has various pros and cons. Arnold is a kind of a photorealistic render engine, and here you can see Arnold kind of in various stages of rendering. So your images will start out very coarse and very pixelated, and then the more light bounces it calculates, the more refined the image becomes. All right, so the settings that you create in each of these areas are going to affect how quickly your scene can be calculated or how quickly the image is rendered. In 3D modeling, you're always balancing between computational efficiency and realistic effects. So that final balance is going to depend on the application and your desired aesthetics. So we're going to be, this view mode option is going to become a little bit more important as we start getting into materials and textures. So if you've hit like a number button and your viewport changes, it's because you're changing your viewport mode. So we'll review that once we get into the textures a little bit. All right, so first things first, want to make sure that you have Arnold loaded. So under our windows, if you select Settings and Preferences and then select down into Plugin Manager, you'll get its pop-up window with all of Maya's plugins. You want to scroll down. There should be a solid angle plugin. It probably doesn't say 2017 anymore. You're looking for this mtoa.mll file, and you want to make sure it's loaded, and then you want to make sure that you've got auto load checked. If you don't have those loaded, just check them and then press refresh, and that should bring those the Maya plugin, download it, and then load it into your scene. You might, if not, if it's a little bit buggy, for double security's sake, if you have a buggy, crashy Maya, you might want to make sure it's checked, or hit refresh, make sure those buttons are checked, and then shut down Maya and then open it back up. All right, I'm going to jump into Maya here and just run through those couple steps. So under Windows, under Settings and Preferences, in your Plugin Manager, you want to scroll down and check to see, oh, it was right there. Yeah, so it's Application, Solid Angle, MTOA. It's going to say 2020 for those of you that have 2020, and you want to just make sure that your MTOA, that's your Arnold file, and it's now a .bundle file, is loaded and auto load. And then you can click refresh and then close. All right, so I've got Arnold loaded. So the next thing that I want to do, what do I want to do? Oh, I want to talk about render settings. So before I start adding any lights, we have to decide what type of image we're going to be rendering and what those properties are. So all of our render icons, first we'll actually want to change our kind of taskbar from our modeling taskbar to our rendering taskbar. That's going to give us a lighting and shading and a texturing and a render option up in our menu set here. So I'm going to, you can get to these windows a couple different ways. I have found there are certain paths through the UI that are less buggy and less prone to crashing than others, so I will use those always. If you find another way that you like to get into the render settings, feel free to do so, but there are two places that I like to go for my render previews that are the least crashy of the render settings. So the first things first, I want to open up my render settings. So there's the little clapboard with a blue gear next to it. That's going to bring up my render settings. And then I want to make sure, the first thing I want to do in my common tab, make sure that I'm rendering using the Arnold renderer. So I'm going to click down to Arnold renderer and master layer is good. In my file output, I'm going to say I want my image format to be a PNG. So JPEGs are great for final outputs for compressed storage, but it's best practices if you are going to be rendering, let's say for personal use, you want an uncompressed file format. So that's either going to be a PNG or a TIFF file. So the TIFF is kind of the gold standard in terms of its compression. You can say no compression, and that's going to save an RGB pixel value for each pixel, which means you have all of the color data for each pixel. When you compress, let's say for a PNG, all of that color data is still there, but it's saved a little bit more efficiently. So it scans through the file. It says, okay, there's 4,000 pixels that are this hex value, and so let's all save those together, and then we'll just save all the addresses together, which is great, but it can lead to problems down the line because you don't have that kind of this pixel is this color, this pixel is this color, this pixel is this color. In a lossless compression, that's like a JPEG, what you're doing is you're saying, okay, this suite of color ranges are similar enough that we're actually going to kind of, although they're like one RGB value away from one another, we're going to compress them down so that they're the same RGB value, which is why you see like color bands and soft gradient areas in a JPEG image. It's because it's blocked down those color bands into the same color, and you've lost that kind of soft gradient. So you don't want to save your files, your kind of master files, in a compressed format. You want to compress them later for ease of transfer, but while you're saving for your master files, the best practice is to save into a lossless compression. I like to use, I used to only use TIFF format. I'm getting a little bit less, I'm getting a little bit more flexible about that, but now I'm saving using a PNG format primarily. Is that true? I am for school, but for my own personal work, I'm actually still using TIFF. But since you guys are going to be submitting these to things like online, PNG should be fine, and then this Int8 should be fine as well for the compression format. So you want to, all of the rest of these settings should be fine. So just set your file name is going to be using the name. It's going to render out and name the file the name of your scene for now. We'll talk more about that. That becomes a little bit more important when you're batch rendering for video sequences. All right, those should all be fine. Renderable cameras, you want to use our perspective view. So Maya will render out whatever view you have live in your perspective view camera if you have this perspective view selected. For now, let's keep it on perspective view. And then the image size, we can, for today's purposes, for this assignment purposes, we can use the HD 540, which is going to give you 960 pixels wide by 540 pixels tall. A resolution of 72 is great, and then the default aspect ratios are fine. So just as a recap, let's make sure you've got your Arnold renderer turned on. Make sure you're using a PNG as the file format, and make sure you have a preset of like a HD 540 is good. Not too big, but not too small. And then you can close that down. We'll talk a little bit later about all of these samples, but I'd like to kind of get us in and working with lights. This has to do with how many times Maya calculates out those light bounces. The more times it calculates out, the kind of more clear your image will be, but the longer it's going to take. So you're always kind of trying to find that kind of perfect balance. Since we're only going to be rendering out a single image, that becomes, it's not as important. But if you're rendering out an image sequence and you have thousands of still images that you're rendering, that becomes really important because it can take a long time to render.